look to see what kind of questions. I think there's only like 5 questions on the test from
Are you
probability.
recording?
So, I'm sorry, what?
I asked if you were recording.
Yes, I am recording. Okay, so probability if I spelled it right, is assigning a number from 0 to 1, meaning a decimal, to a prediction based on experience, logic, or stats. I'll give you a prime example. Everybody has gotten behind one of the blue-haired ladies club, one of the little old blue-haired ladies club in a car. And little old blue-haired ladies club, they only go 33.2 miles an hour. And you're on a 2-lane road that's about 16 miles long, and you can't pass because there's oncoming traffic. Most sensible people would just sit there and wait, because if you tried to pass, you would get a head-on collision. And you get to the end of the road, and you can only turn left or right, and you're going left. And you say to yourself, I bet you $1 this woman's turning left. And just as soon as you do that, she turns on her left turn signal. And that has happened to many of us. I know it's happened to some of you. But did you foretell the future? No. No one can foretell the future. Okay? If they tell you that they can foretell the future, all you got to do is ask them one question. What's the one question you need to ask them? That means I want y'all to say something.
What am I about to do? I don't know.
No, come on. You got one wish, one question. What would you ask somebody if they could foresee the future? What would you ask them?
What are the lottery numbers?
Exactly. And what will they say? Oh, that's not what I do. No, that's not what you do because you're a fraud. Okay? Nobody can tell the future. How many of you have heard of 20 questions before?
Oh, the game?
Yeah.
Yep.
Tell us how to play, Miss Grindle. Tell us how to play 20 questions.
Basically, you pick a topic. It could be anything. Let's say you pick, I don't know, a zebra. And the 20 questions asks you basically 20 questions and tries to guess off of those answers what your topic is you picked.
Okay. So if I dress myself as a fortune teller and I was a good people analyzer, in other words, I watch people and their expressions, and I've got a degree in psychology, and I ask a lot of questions, I could pretty much tell you that you might be a depressed person looking to get married and have children. Or I can tell you that you are a depressed person looking to get married and get a good job and blah, 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 blah. Because I can take deduction and I can use these other things to basically con you into thinking that I can tell you your what? Future. There ain't nobody that can tell you the future. Now, can we take statistics and can we extrapolate, calculate, interpret, and put a prediction on something? Yes. But are we foretelling the future? No. Foretelling the future is being able to tell that something has already happened, to be able to predict when it's going to happen because you know of it, because you saw it into the future. Okay, that's telling the future. Y'all seen Back to the Future 2, right?
Yeah.
Okay. What did Marty McFly have in his pocket when he went into the future that was a big no-no?
A cell phone?
No.
I don't remember.
Remember, he got it out of the pawn shop.
A watch?
Sports almanac. Or almanac. What would the
I've
sports
never
almanac
watched Back to
get?
the
What would
Future.
that do? If he took that back into the future or back to where he was from, what could he do with that sports almanac?
He could bet against it.
He could bet on it. Now, that would be foretelling the future because he had the future in that booklet.
Yeah.
Okay? That would be foretelling the future. All right? So if anybody walks up to you and tells you that they can foretell the future, I had a friend that used to tell me that she could take my dreams and she could tell me the future from my dreams.
That's creepy.
I thought she was a nut. Okay? You cannot tell the future, period. But you can say, well, you know what? I've been traveling this road for 16 years, and there's 3 rights I could have made, or this woman could have made, to go to Sandy Springs, but she kept on going, so she either going to Pendleton or Clemson. That's using logic and deduction. Okay? It's using experience. She didn't turn right anywhere because she wasn't going to Sandy Springs. She was going to Pendleton or Clemson. So naturally, when you got to the end of the road, I'm talking about Wild Hog Road, when you got to the end of the road, she's not going to turn right because she could have turned right on 3 separate occasions going down Wild Hog Road. So logic dictates that if she didn't turn right on those 3 roads, then she was going to turn left when she got to the end of the Wild Hog Road. So that's logic and experience. So, you know, people can dress up and they can use forms of 20 questions or deduction, or people watching people, you know, have a degree in behavioral sciences and ask you a bunch of questions, and they can nail you pretty much what you're looking for as far as relationships, as far as a career, as far as, you know, things that you look for in the future. So don't be conned. Nobody can foretell the future. But we do use probability to put a prediction on something. There's 2 types of probability. There is the physical probability, and there is the theoretical probability. Theoretical is based on math. Physical is based on observing. Okay? Sometimes the physical is called the classic probability. You might see it called classic. Theoretical is always called theoretical. Both of them circle around the probability of something. The probability of an event is the probability of that event happening over the probability of the events, the total events that it could happen, or all the events. Same thing here. Probability of an event happening is the probability of it actually happening or over the total number of events that it could happen. Give you an example. Let's say, how many of you in here, raise your virtual hand, how many of you familiar or consider yourself familiar with a deck of cards? Okay, I got 3 people. Okay. Okay, you can take your hands down now. Miss Mia. What if I asked you to tell me what is the probability of a king out of a deck of cards? Of picking a king out of a deck of cards. Could you tell me that?
I guess I would say unlikely.
No, the numbers.
Oh.
Yeah, it would be unlikely. Yes, you are correct.
Okay.
But what would the numbers be? Do you know?
Like how many would be in the deck?
Yeah, out of 52 cards, there's 52 in a deck. How many kings are there?
I would say 5.
There's 4.
4.
Okay. So, Miss Mia just told me that the probability of a king in a deck of cards is 4 over 52. Now, she didn't have a deck of cards in front of her. So tell me what this was based on.
How many cards are in the deck?
I mean, how do you know? You don't have a deck of cards in front of you.
Because there's typically 52 cards in a deck.
Exactly. It's from something that you already know, meaning what? Technically, the mathematics of the deck of cards.
Experience.
All right? It's something that you already know. Like the probability of a 6 on a die, which is one of the cubes. 2 of them is called dice. One of them is called die. The probability of a 6, rolling a 6 on one die, is 1 over 6.
Right.
Now, I don't have a die in front of me, but I know that. Something else. If probability of heads on a coin be 1 out of 2. Those are all theoretical probabilities. A classic probability would be taking a coin and flipping it 100 times. So that would be something that you actually did. And I am out of black. Use brown here. So if I did 100 flips of a coin, and got 48 tails. Therefore, the complement would be, complement is what makes up the whole. What's the complement of 48 to 100? 52 heads. So the probability of heads would be 52 over 100. Probability of tails would be 48 over 100. Now that's the difference between an event and theoretical. Now, will these two numbers be close to each other? No. They will not be equal. And I'm going to put that in red. So you need to remember that because that's going to give us our next page of notes. They are not equal unless it's just by coincidence or large number rule, the rule of large numbers, the rule of big numbers, whatever you want to call it. That's the next page. The law of large numbers. The law of large numbers says and I'm just going to put it, that's not supposed to be there, says the more you try the closer the physical probability will approach the theoretical probability. Let me give you an example. At MIT, there was these 2 students, and these 2 students were computer programmers. And this is a true story. And they took a roll of quarters. They took a roll of quarters, which is how many? 40 quarters?
Yeah, I think so. About 40, 50.
And they measured, they weighed, they did a laser scan of all 40 quarters, balanced, found out all of them was balanced, and they made a virtual quarter. They took those 40 quarters and they created a virtual quarter. And they programmed that virtual quarter into a computer program, and they flipped that quarter until they got the probability of tails with the physical probability to equal the probability of tails with the theoretical probability. Does anybody know how many flips it took the 0.5 of the theoretical to equal the 0.5 of the physical? Anybody want to take a guess? How many flips?
I have no idea.
Anybody want to take a guess?
Is it a small or big number?
That I'm not telling you that. Might as well tell you if
Well, that could help.
I got a job or not.
Okay.
100,000 times.
Okay.
Turn your mute on, please, Mr. Pack. 100,000 times. So, what does this mean in probability and statistics? The more you try, the more surveys you put out, the more accurate your data is. So we need to put that in green. The more you do, the better the numbers. Hubert's rule of life, number 4 or number 3. You get out of it what you what?
You put in?
What you put in. You get out of it what you put into it. Kind of like Bar Rescue. I cannot stop watching Bar Rescue. Those people, they don't put anything into the bar. They just sit around and do nothing, and the bar goes under. Same way with anything else. If you suck at something, you're going to pretty much just going to go downhill. So you either get better at it or you what? You find somebody to get better at it. The more you put into something, the better the numbers are going to be. That's the law of large numbers. And that's true in probability, statistics, economics. It's true with anything. The more you put into something, the better off you're going to be. Now, let's talk about some probabilities. Here is one that I wrote off your test. This is a test question that I just got off your test. The veterinarian has treated 50 dogs, 45 cats, 5 birds, and 10 rabbits. Now, the first thing you do when you're doing probability, and this is in red, find the total, because the total is usually your denominator. Find the total. That's the number one. That is your number one thing. Find the total. So you're going to add all these up. That's 95. That's 100, 110. So n is equal to 110. So your denominator is pretty much going to be 110. Second, read the question. Now, I really want to underline read because some people don't read the question. And it'll say, what is the probability of the next patient for the veterinarian being a dog? Well, that would be 50 over 110. There goes my mouse. Okay. Now the cardinal rule of, what is the cardinal rule of fractions? You always what? Starts with a R.
Reduce.
Reduce. You always reduce fractions. And in probability and statistics, you always write as a percent, as a decimal. So that would be 5 over 11, which would be, I don't know, 11 will go into 55.5 or something. What is it? 0.55? Somebody take 50 over 11 in your calculator and tell me what you get.
It's like 4.5 repeating. 4.5.
There's
0.45
repeating. Remember, all the decimals have to be between 0 and 1, so it can't be 4.5. Is it 0.45 repeating?
Yes.
That didn't sound too confident. Yeah.
I can't help you there. I'm driving.
Nobody's going to help me today, so I'm just going to go by Miss Grindle. What'd she say? She said 0.45, and that is the probability of his next customer being a dog. Well, what's the probability of the next customer being a rabbit? Well, that'd be 10 out of 110. So we do that in orange. Probability of a rabbit. That will be 10 over 110. Somebody give me that decimal, please.
0.01.
0.01. That 0.45 seems a little high. Let me do it in my calculator. I can't use the form. My mouse is destroyed. So I got to use my track, whatever it's called. I don't like it. So 0.5 or 50 divided by 110. 0.45. I'm sorry. I just looked awfully. Yeah, 50. Yeah, 50 out of 100 is 0.5. Okay. So that's the test question on the test. So at least most of y'all can get one right on the test, because that's one of the questions. I'm trying to get my mouse. I'm sorry. I'm trying to reach the battery.
Come on.
Okay. So I'm going to give you one here in just a minute. I'll give you two more questions that you'll see on the test. And I'm going to put my mouse back together because I cannot stand using this mouse pad. All right, I want the probability. Now, one or two of these can be a trick question. You got to be careful. Probability of a king. Well, I already did a king. So let's do a heart. Probability of a heart. Probability of a 7 on a die. And the probability of a even number on a die. Okay, so work on those three while I put my mouse back together.
So what, is it a 14 out of 54 for the heart?
Say again?
Isn't it like 14 out of 54 for the heart? Because like there's a heart for each thing, and it goes up to 10, and then you count for the
I'm going to show everybody that in just a minute. There's 13 hearts.
I was one off.
That's all right. There we go. Okay, now I'm going to go to the deck of cards, go to Google. I'm sorry. Deck of cards. And I would print that out if I was y'all. Image. And there you go. There's your deck of cards. That's not organized. Let me find you one that's organized. There's one that's organized. There you go. So I would save this, save image as. Just showing those people that, you know, never do what I say. Maybe one of them might do this. Deck of cards. Pull up my handy dandy word processor. Fix layout, landscape. Margins to 0. And insert picture. It's a lot of work, I know. A lot of work. And there you go. Let me erase this, get this out of the way. There's your deck of cards. So, if you count the hearts, you got 13. So that would be 13 out of 52, which would reduce down to 1/4, which everybody knows that 1/4 is equal to what? 0.25. What is the probability of a 7 on a die?
A 7.
Does
Isn't it
not
like
exist.
1 out of 7? Oh, no, yeah, 0, because the 6-sided die.
There's only 6 sides on a die.
Unless you have a special die.
Well, actually, this is a test question, so you might want to, and it's a standardized test question also. There's only 6 sides on a die. This is the trick question I told you about.
But I say because there's different kinds of dice, and some of them can go all the way up to 20.
Well, they're called different. They would say that in the question. When they say a die, they mean a 6-sided die.
Okay.
Because if they gave you the other sides, they would have to give you the other sides if it was possible. In other words, if it was a tetrahedron or if it was a pyramid die, they would have to tell you that. But if it's not said, it's assumed it's a 6-sided die.
Okay.
Okay, even number. Well, on an even number on a die, there's 1, 2, 3, 4, 5, 6. And 2 is even, 4 is even, and 6 is even, so that'd be 3, out of 6 sides, which is point what?
5.
There's several test questions right there on probability. Now, the second part of the probability section, which is, I don't forgot what chapter we're on. Let's see, 11.2. I just showed you 11.1. Real simple, it's not hard. 11.2. 11.2 is odds. Odds against. Now, why don't I use odds in favor? Well, the odds in favor, that's not right. Anyway, odds in favor is the reciprocal of odds against. So if you have the odds in favor, you can flip it and get the odds against. If you have the odds against, you can flip it and get the odds in favor. So what is the formula for odds against and odds in favor? Odds against is the probability of failure over the probability of success. Therefore, the probability, the odds in favor is the probability of success over the probability of failure. Well, what is the probability of success and the probability of failure? Well, that depends on the question. If I ask you, if you roll a die, what is the probability of rolling a 6? Then the probability of rolling a 6 is success. The probability of not rolling a 6 is failure. Depends on what the question is asking. All right? Some things you need to remember on this one in red. Number 1, read the what? The question.
Question.
One thing about probability, if you don't read the question, you may get an easy problem wrong. Read the question. 2, when you're dealing with odds against and odds in favor, always use fractions. Because what happens is, when you get toward the end of the problem, the denominators are going to cancel out. And it leaves you with a simple fraction at the end. Okay, always use fractions. Do not use the calculator. Okay, and of course, the third thing is they are reciprocals of each other. So if you can find one, you can find the other. Okay, because on a test question, they may ask you to find the odds against, and then they may say, well, what's the odds in favor? Well, that's just a flip-flop. Why do I worry about this one? Because this one is the one that's used in gambling. And that's the one they test you on the most. Odds against. Okay, so I'm going to give you a perfect example of one that they would give you on a test. Okay. A roulette table. Let's show you what a roulette table is for those that don't know. Go to our handy dandy Google and type in roulette table. Roulette wheel, whatever. Everybody knows what a roulette wheel is now. Now that I showed you one, there's one right there. See it? Everybody see the green numbers on it? There's a 0, 00, and a 0, and then the rest are red and what?
Black.
Red and black. You can bet on several things here. I'm going to write a question on the handy dandy whiteboard. On a roulette wheel, there are, let's see, you may pick a big number. I see a 33. I see a 35. Does anybody see a number bigger than 35?
Eh,
I'm
36.
looking. You do see 36? Lap turn, where is it? Oh, there it is, red. All right, 36. There are 36 red and black with 2 greens, 0 and 00 that are neither even or odd. Okay, so there's the question, and it'll say A. What is the probability of the ball? You know, you spin the wheel one way, and then you roll the marble the opposite way, and then wherever it falls, that's the winner. What is the probability of landing on black? Okay.
Oh wow!
Then
I
it'll
feel crazy. I
say
can't answer that because I went to school for that.
It'll say what are, I can't talk, spell or talk. What are the odds against black? And then it'll say, what if you bet? What if you win? I cannot write today. What if you win at a $500 bet? So let's say that I bet on black. And I know the odds, and I put $500 on black. And if you look at the table, you can actually put on black. Somewhere around here it says black there. You put your chips on black right there. All right? That way, if it hits a black number, you win. Everybody with me?
Okay.
Anybody understand it?
Yep.
Okay. Now I just got to find the probability of black. Well, half of these numbers are black and half of them are
Red.
So I'd take 36 and divide by 2, and that'll give me the black and the red.
18.
So 18. So the probability of black is 18 over 38.
What about the 2 green numbers?
Hold on.
That's what I was gonna say.
Y'all stealing my thunder. Can y'all wait a minute? I mean, damn it. All right. So I'm going to put down here the probability of black, and then I'm going to put a red X by it. And what does that mean? That means not black. So the probability of black, and I'm going to take my red pen, and I'm going to put a big red X through that black right there. And somebody tell me that probability.
Should be the same.
Nope.
Oh, okay. I don't know then.
Would that be the 20 over 38?
Good job. 20 over 38.
Okay. I got it.
Now, somebody tell me which one is winning and which one is losing. The question said, you bet on black. Hold on a minute. All these markers over here are going in the trash can. So if the question asks, you bet on being black, wouldn't that be winning?
I mean, if it lands on a black number, then yeah.
Yeah. So if the marble lands on black, that's a winner. So the odds against is equal to the probability of failure over the probability of success. So somebody tell me what the probability of failure is. That's losing. What is that?
38.
20 over what? 38.
Okay.
What is the probability of winning?
The opposite of that.
18 over what? 38. How do you divide a fraction by another fraction? You multiply by the what?
Bottom.
Y'all are forgotten y'all's first chapter already. You multiply by the reciprocal. Oh my, look what happens to the 38s. What happens to the 38?
I said that.
Well, I can't hear you. All right. So that was the odds against is equal 20 to 18 or 20 to 18 or 20 to 18. And you can simplify those. 2 will go into, that'll be 10 to what? 9? 10 to 9. 10 to 9. Those is reduced. So there is the odds against. So what do you do with that 20 to over 18? You multiply it by 500. 20 over 19 multiplied by 500. I'm going to give you another problem in just a second, but we're not going to bet on the black or the white or the black or the red. We're going to bet on a number. So what is, take your handy dandy calculator, and 20 divided by 18, sorry. 20 divided by 18 times 500. So on that 500 bet, we won $56. That sucks.
That's that's pretty shitty.
What?
I said that's pretty shitty.
Well, we're going to get to why in a minute. So we won $56, which is real crappy. Let's change this. Let's change this question right here. Let's say on a roulette wheel, and I'm going to let y'all do this one. Use this as a template. On a roulette wheel, there are 36 red and black with 2 greens, 0 and double 0, neither even or odd. That's 0 and the double 0. A, what is the probability of landing on 7? B, odds against landing on 7. And what would happen if you made a $500 bet on 7 and won? All right, now I want you to do that problem. I'll give you a hint. The probability of winning with 7 is 1 out of 38. I'll give you that hint. One probability of winning with a 7 is 1 over 38. Therefore, the probability of not winning with a 7, which would be failure, I'm going to let you do the rest.
Sorry, that's my cat.
That's all right. Cats are loud. I just don't want to hear no dang dog barking. That cat just told you as a menial human that it either needs attention or it needs food.
She wants me to pet her.
Exactly. That's what you're supposed to do. Cat commands. Okay, so tell me what is the probability of losing?
Get down. Go on.
What is the probability of losing? If the probability of winning is 1 over 38,
38 to 1.
what's the probability of losing? If you win one time, how many chances of losing is there? It's got to be a fraction. 37 over what?
37 to 1.
Over 38.
38.
Y'all, you're thinking of odds.
Yeah.
You haven't done the odds. You got to do the probability first. So the probability of winning, is that ball falling on 7, is 1. There's only 1 7 on the whole wheel over 38. The probability of losing is 37 over 38 because there's 37 other slots besides that number 7. So the odds against, or the odds of failure over the odds, the probability of failure over the probability of what? Success. Multiply by 38 over 1. And the 38s cancel, which is supposed to happen all the time. And you're left with 37 to 1. Multiply that by 37 over 1. And 37 times 500. You walk home with $18,000 more than you left with. So, what have we learned with this problem? Well, somebody tell me, when we went with black, what was our probability of winning? Was it high or low? 18 over 38. Let's do 18 over 38 in the calculator. 18 divided by 38. Gosh, almost 0.5. So somebody tell me, when we picked a red or green, no, not green, or a black, a red or a black, what was the probability? Fairly what? High or low?
High.
Yeah. Probability of red or black was around 0.5, which is high by gambling standards. So if the probability is high, the odds are going to be what?
Low.
What's the opposite of high?
Low. Low.
Be low. Therefore, you won't win squat.
Not with that attitude you want.
What did y'all say? What did y'all say when I said you take home $56? What did y'all say? Miss Grindle, what did you say?
I said that was shitty.
Yeah, you won $56.
56
Woohoo!
more dollars.
Yeah, I suppose.
Beggars can't be choosers, right?
I'm telling you, if y'all were in Vegas and you bet on a roulette wheel and you come away with $56, you would go, crap, I want to play again.
I mean,
But-
that could be a nice
I-
dinner depending on where you go. So
No, they pay for your food when you go. They pay for your drinks and everything. All
I
they
mean,
want you to
I
do
wouldn't gamble.
is gamble. But when you bet on one number, let's see what that probability is.
that's gonna be really low.
1 out of 38. Somebody tell me what this probability is. That's very what?
Low.
Very low. And if your probability of winning is low, what is your odds?
Of losing is high.
Odds will be high. And if your odds are high, you're going to take home $18,000 versus $56. $18,500.
I'm going on a vacation with that.
There you go. That's what I'd buy me a new truck. Not a new truck, a truck the same age as mine. That's what I want. So I want y'all to write this down in layman's terms in your way. If the probability is high, the odds will be low. The prize will not be very much. If the probability is low, the odds will be high. The reward will be very much.
That's 116, by the way.
I know. We're done. We're done with those questions that I just gave you. Basically, I've covered what's on the test from chapter 11. So I need you to work on 11.1 and 11.2 Wednesday and Thursday. Wednesday and Friday. We work on nothing but homework problems
When is
from all the different chapters that you want to work on. Say again.
It says the test already opened.
I think so. If not, I'll open it probably the next day or two. Well, yeah, I guess I can go ahead and open it. I'll open it up.
Yeah, the only test that's open is Unit
I
3.
probably want to wait till Wednesday. Let me wait till Wednesday to open it up.
Okay.
Questions?
Unit 3 test is open, but that's the only one open, I think.
Yeah. All right, I'll check it and I'll open it up. I think might open up everything. All right. Y'all have
Hey,
a good
I came
day.
in late.
See y'all Wednesday.
You
Gilbert,
too.
I came in late.
I'm not taking roll. This is last week's class. I'm just going to put everybody here.
Okay.
Fair enough.
Thank you, Miss Hunter. Bye-bye.
Bye-bye.
Have a good one.
Bye-bye.